Hi all. Harun requested this video, and I think this is question 7. This is question 7 on the second assessment on the AAT website, and it's really looking at limiting factors. So let's discuss it. It starts off by telling you that a business has 1,600 kilograms. And it's quite a good question in that it tells you that it is the limiting factor. It tells you there's a shortage of this material due to a strike, which is expected to last for a month. So because we know it's a limiting factor, we're sort of halfway there, if you like. Like we did a question, I think, on Monday where we had labor and material, and you had to actually just work out the total amount of labor and total amount of material that you needed in terms of demand. And once you work that out, you would then know how much you needed and how much you had. You could compare and actually find and discover what the limiting factor was. So in this case, we're told straight away the limiting factor is 1,600. And you're told how much you need in total. You're told you need 800 here, 480 here, and 720. So let's just literally fill in the boxes. So we're told that, first of all, which kind of makes sense, we're told to sort of work out what the material required is per unit. And in terms of the material required per unit, as you can imagine, that must be for product X. One second, sorry. That must be for product X. This question of, well, if you need 800 kilograms to make 400 units, well, that must be 800 divided by 400, which must be 2 kilograms per unit. Here, if you need 480 kilograms to make 600 units, well, that must be 0.8 kilograms per unit. And here, if you need 720 kilograms to make 400 units, that must be 1.8 kilograms per unit. Then they ask you, what's the contribution per unit? Well, let's look at contribution. Contribution is selling price minus variable cost. Selling price minus variable cost. Selling price minus variable cost. So the contribution for product X, here, I'll just write contribution here so that we have it ready. Here is £2.50, and here our contribution is £1.60, and here our contribution is £2.70. But the question is asking, what is the contribution per unit? Oh, sorry, that's the contribution per unit. So we even have a space for that. So £2.50, £1.60, and £2.70. Brilliant. Then they ask you, what is the contribution per limiting factor? So if the limiting factor is the kilograms that you need, it's really saying what is £2.50 divided by the 2 kilograms, right? How much contribution are you gaining per kilogram or per limiting factor? £1.60 divided by 0.8, and here £2.70 divided by 1.8. And when you do these, I'll just change my pen color. When you do these, you should get 1.25. Here you should get 2, and here you should get 1.5. Ultimately, you should have another column, technically like rank. When I say rank, who should I make first? And you always make the one that gives you, I'm just going to write it here, who should you make first? And that's the one that gives you the highest contribution per limiting factor. You make this guy first, you make this guy, because that's 2, that's 1.5, and that's 3. So, well, if we're making product Y first, well, we have 480 kilograms. Well, I mean, we have 1,600, so we can make them, so we can make 600 units, not a problem. Then we're making this, means we still have capacity for this, so we can make the 400 units. So the question really becomes, if you have a total of 1,600 kilograms, and you have now used 480 kilograms, and you've also used 720 kilograms, well, that means you've used 1,200 kilograms so far. So that means you have 400 kilograms left. If you have 400 kilograms left, you have 400 kilograms for product X, and you know you need 2 kilograms to make a unit of product X, right? Because we worked that out from here. So you need to read the question and sort of investigate and see what's really going on. So if you need 400, if you need 2 kilograms to make 1 unit, that means you can make 200 units. So your optimal point is 600 units of product Y, 400 units of product Z, and 200 units of product X. And then what do? We go ahead and we calculate. I think then they ask you to. So that's kind of that. And they ask you to work out the profit, if you like. Well, I mean, really, profit now is just very much contribution. Let's work out all the contributions, and the contribution is for. Let's do product Y. Contribution is £1.60 times 600 units. You work that out. For product Z, you have £2.70 times 400 units. You work that out. And for product X, you have £1.25 times 200 units. You work that out. And it tells you overall you have, I believe, 755 or something along those lines. Yeah, 755. The fixed cost of 755. And your answer should give you the profit that you're looking for. Right? Cool. Awesome. And then I think the next bit's a written sort of bit, and they're sort of asking you, why is this the best option, so to speak? Well, fundamentally, we have a scarce resource. And really, the question is, we want to get as much from that scarce resource as possible. Anything else will not give us this. And, well, the other thing is, we must assume there is an assumption, a strong assumption, that we have covered our fixed costs. So everything after this is just adding to, is just contributing to profit. And this thing here, what we're getting here, is just contributing, technically, well, it's contributing to profit. Well, there is an additional fixed cost, so to speak, but the argument really is that everything we're making post with this resource, it's just the best we can do with this resource right now. So the argument really is that arrange it this way, and then you can see, you'll be able to sort of see what the best options are. Anything else would just give you less contribution, really, because the question is, what is generating the greatest contribution for scarce resource, and that's what we're trying to achieve, and that's the efficiency or productivity we're trying to achieve. Okay. So I mean, read up the marketing on the written, just to buttress these points, but in terms of the calculation, this is where we're going. Cool, great stuff. I'll answer the next one now.